Hello and good morning. And the day one speaker certainly set a high bar for us day two folks, but thank you very much. I'm Ryan Guest. I'm a principal software engineer on Amazon's core privacy team. And today I'm going to be talking about lessons learned deploying the global privacy control to millions of our customers. This thing. Unfortunately, when I tell folks in industry I work in privacy engineering, this is the first thing they ask me about. Oh, you work on cookie consent, cool. And I'm like, yeah, and also this other cool, really cool stuff that I'd like to talk about instead of this, but this is kind of where we are. And to be a little vocally self-critical, I think we can do better. I think we can do better at this. Obviously, I don't have the answers, but this is one of the reasons why I was very interested when I heard about this thing called the global privacy control. And so the global privacy control is a specification designed for internet users to opt out of their personal information being sold or shared. Some folks may remember DNT, Do Not Track, which was a precursor to this. Do Not Track is now deprecated and was kind of an earlier attempt to kind of get here, and I think some lessons learned from that ended up in the GPC. And so all it is, really, is a header sent in a request with a value of 0 and 1. It's a Boolean. So pretty simple, pretty straightforward, which was encouraging. But with this, we hit a couple of ambiguous areas and rough spots in our deployment, and I'm going to share some of those. So one is that 1 represents an opt-out, saying I opt out of this. A 0 is an explicit I don't opt out. And you can also get no header or blank header or empty header. And we saw all kinds of junk that we got in our production service. People passing their email address in there, passing a Shakespeare manuscript. You know, it's the internet, right? You see all kinds of stuff. So the spec says 0, 1, but in practice you see everything, so you have to handle it accordingly. And I just want to preface, for some of these sort of ambiguous, less technical type conversations, your legal and compliance team will definitely be interested in talking to you about what you do, how you handle things, and how things go. So the 0 and 1, like I said, you're going to get a bunch of junk, but most part, folks try and do the right thing are going to send you a 0 and 1. As engineers, sometimes this binary option is limiting, and so we had a tendency on our side to try and okay, how much different stuff can we stuff in here? Right? It's like, no, you can't. Like, it's a 0 or 1. And engineers kind of, when they see a protocol, is like, oh, what else can we add in here? What would be nice? So what are we going to need later? I'm like, no, it's a 0, 1, and that's all you get downstream. So you have to deal with that accordingly. With the 0 and 1, they come in weird orders. So you get 0, 0, 0 a million times, and then a single 1, and then a million more zeros. And you have to say, oh, well, what does that mean? Do they opt in? Do they opt out? What's going on? And all the different binary bit set combinations you get, you'll see. For the most part, you'll see things pretty consistent, but there's always those corner cases, and for privacy engineers, I think we're attracted to those corner cases, and that's where the fun is. The other thing that was interesting for us and the lessons learned is that on our server, these don't always come in order as from the client. So we have a bunch of internal systems that make this probably overly complicated. We've got things that are first in, first out, last in, first out. So by the time the downstream service or server that actually needs to respect this gets the value and may have seen previous values, it doesn't necessarily know that this is the order it came in. So we did some things on our side, like tacking on, when was the date that we saw this, or a timestamp or things, so folks could reason about that. The other thing is the spec is pretty intentional about there's no versioning, but as engineers, we kind of we're going to have a version. Things are evolving. That's a good thing. That's a very good thing. So one thing we did that helped us a ton was we started adding versioning information. To what version of this, our own internal version, did we see? We stuck other audit details, like I said, timestamps. So if you're debugging these things, like why did I see this value? It was certainly helpful. And so as you persist or store or deal with these things internally, I would highly recommend tacking on those things, because then if or when versioning comes, you're ready to go. And this isn't always only an HTTP header. There's a cool thing in the browser where some browsers now support navigator.globalprivacycontrol in the JavaScript API. And so this is very cool if you're on a client where you don't want to reach back into the headers. On the front end, you can see, OK, was this passed? A 0 is false and a 1 is true. And so it's pretty straightforward. Of course, browser compatibility is the whole thing itself. So this is undefined a bunch of places. You want to take care of that. And to be honest, for Amazon and our deployment, I just looked in the code base last night, we're hardly using this at all because we're such back-end heavy. The header was consistent. It was easier to do one thing and then send that everywhere. But if you are more front-end stack heavy, this is definitely useful. For us, I thought it would get more use than it did in practice. The other thing to think about is your customers, obviously, and how they're going to handle some of these things. So at Amazon, we value transparency a lot and for customers to know what's going on. There's nothing inherent in the protocol to say from the client you can send it, but the server say, yeah, I got it, and I'm actually respecting what you said. Which we found ourselves kind of reaching for something like that to be like, oh, how do we tell them we actually got it or we didn't get it? They may have the intention of setting it for whatever reason. We don't think it's set, and allow them to kind of know what's going on. So you're going to think about options for that in your customer experiences, your user experiences, if there's a way to represent that. So customers clearly know what's going on. That's something extra we thought that was important. What's also interesting is that this being new, we have a whole legacy of different preferences, opt-in, opt-out settings you can set. And we had to take this new thing and say, okay, how does this gel with all those different combination of options we already had? And that got pretty difficult at times. And what I was saying back, talking to your legal and compliance teams, is you have to make some decisions like, oh, I'm getting conflicting signals, or I'm getting one signal says this, another signal changed, and do I do the recent thing? Does one of these have precedence over the others? There's some difficult things to figure out, to figure out how they gel internally for your organization. I mentioned this is an evolving standard, so browser compatibility isn't quite there. I stole this from Mozilla. Firefox has a version 120, has the green check, but all the other ones have still, are implementing or a different phase of implement. Some are in beta and pretty mature, but it's not real world deployed everywhere yet. As I mentioned, Firefox and Brave, I think, sends this by default now, which is interesting. On the service side, Amazon, Nike, and the New York Times, and a bunch of others have already implemented this to be able to send the signal. And then the other thing to think about is, mobile devices are kind of all over the place, and there are different devices and mobile form factors handle things differently, and so that's an evolving area. Other things that we have is like speech, like Alexa. We say an Alexa command, how does that interact with global privacy control things set everywhere? And so we're talking about conflicting signals. You have to figure out how that interacts and make sure that your different things besides a human on a desktop on a web browser also respect this if it's been put in place elsewhere. Another difficult thing with trying to figure out if someone sends an opt-out preference is who actually is this person and who is their identity? Trickier than we thought. So if someone logs in and you have a cookie or you have some type of identifier authentication token, cool. Like that's straightforward. That's the paid path. Where this gets tricky is if they haven't logged in yet, and so you don't know who they are, but then they do log in. Is it the right thing to kind of transfer that information to their logged in session so you don't prompt them again or change behavior just because someone logged in? That's generally not the right thing to do. There's a bunch of weird things where it's like someone logs in, logs out, logs in with a different username, logs in with someone else on the same user agent. And that's weird. And times we have a partial cookie, and so we're like, oh, we can kind of think we suggest who they are, but we're not sure. So you have a bunch of weird identity problems there. The other thing is, people use the internet differently. There's kiosks that are around where folks may use shared devices where one device and one user agent has multiple people using it or multiple profiles in that user agent. Think about those and how those interact together. And so this is a slide that I'm sure many of you have seen a form of this many different times. Like architecture, it's complicated, big distributed system. And I mentioned earlier some of the technical challenges we had. The spec being pretty straightforward, just read this HTTP header. Reading an HTTP header from the client in a backend system is not always the most straightforward if you have a big complicated thing where some things are serverless, some things are stateless, and trying to figure out what's going on. We spent a lot of time fleshing out and making sure that things could read right there on sort of our non-paid paths. There's a bunch of asynchronous stuff we do. So in the background, you may purchase something on Amazon, but then a whole 10 different workflows kick off. And so if any of those need to respect the control, you've got to figure out, okay, how does that go? And then you have the ordering thing again, where first in, first out, last in, first out, how are those going to work? Different notification systems, messaging and queuing systems all have to kind of take this into account. And the last thing that we spent a bunch of time working on was different proxies and network appliances who will by sort of design drop headers that they don't know about. And for the most part, like for security, like that's great, cool. We know we're getting this fixed set. Like, oh, now we need to put this on an allow list and we need to chase down all those weird things that people deployed 10, 15, 20 years ago in these random places and be like, oh, actually, no, this one's okay. You have to not only allow it, but then you have to do this thing now that you're reading it and track that down as well. So a bunch of sort of huge distributed systems, internet scale type problems as well. So cool, thank you. I want to thank the PEPR and the program committee for inviting me. Definitely look forward to seeing how the GPC evolves, and hopefully these lessons help you as you roll it out to your companies. Thanks.